Hey guys, in this video we will learn about how we can calculate steel quantity of foundation, slabs, beam, columns using a formula customization technique in Planswift software. In our previous video, we have learned all these topics one by one, and we have also learned this process, rate analysis. So our main concern is to calculate the steel quantities for foundation, slabs, beam and columns. So let's start over today's videos. First of all, using formula customization technique. First of all, normally in formula customization technique we must have to add these tabs one by one: weight of steel, dia, spacing, as we know that detail of steel of RCC of any foundation, slab, beam and columns is already given to us in structural drawings. So from structural drawing we can put here dia, spacing of bars, center to center, and you can say sides of what this is. You can say its size you can say it as a longer side or a shorter side of this is actually a length of that foundation, slab, beam and column. Okay, after that unit weight of bar should be required, and after that we must have to add a cover. For total cover should be equal to cover length multiplied with the number of cover and number of times that cover should occur. After that total length should be there, and at the end you can add extra length. Actually, suppose this is our RCC slab and we want to calculate this steel quantity for this slab actually. So using a formula customization technique, first of all you must remember that the length of bar should be you can say it as a bar should be can be bent up bar or a containment bar. Okay, so there is some extra length which should be added in side of on this side B for this bar, and this extra length you can calculate using a formula of triangle with an angle of 45 degree, or you can add a extra some approximate length which is usually we use in estimation. A standard extra length should be added in the side of bar, total side length, which is normally extra length, which is normally total length multiplied by 1.2. this is a total length actually of that bend bar. So 1.2 is a factor of safety for extra length actually. Okay, always remember, don't forget to add this value, or you can add accurate value using triangular formula and calculate this hypotenuse length actually. Okay, so here is the formulas for calculating number of bar from along the side B. Side A should be divided by the spacing of bar, center to center, plus 1 is the number of total bars along the side B, and again respectively for the same for the side A actually. After that total length should be calculated. Total length should be equal to number of bars, total number of bars multiplied by the total length of bar, which is actually the side B, multiplied by the factor of safety which is extra length actually, which is 1.2 actually. So this should be formula in our customization technique. So always remember, don't forget to add this value. You can increase this value, but you should use minimum this value at least. Okay, after that to calculate the steel quantity, simply unit weight of bar, unit weight of that bar which we are using in this slab actually. After that this should be multiplied with the total length of the bar. So this result in kg or a tons of which is actually the weight of the steel. So hope so you get an idea about some idea about how we can calculate the steel quantity actually. After that extra length could be for bends, for lappings and etc. So it is normally in rough estimate or in normally tender or bidding process estimate, we must prefer to add extra length with a factor of safety 1.2. normally we don't bother to calculate the every band length and number of bands and should multiply with the total sides, and after that we calculate the total band. We don't bother to do this so many process, so we normally add 1.2 simply in our bidding or tender processing estimate in or detailed estimate for the tender bar required at the site, or for the bars you can say purchasing at site from the industry. So for this you can use exact length, lapping length, bend length for this. So formula, the concept will remain same behind this. So main thing is just correct concept behind this. Okay, always remember. So increase your concepts. Okay, so let's start. First of all, suppose this is my slab or rock foundation actually. So to calculate we must go to template and go to test, and now we have to add a new count actually here, new count with a steel quantity of what, foundation. This could be foundation or you can say slab actually. Okay, go to advanced. Now what tab should be added? Normally I always remember these tabs should be added. So first of all we must add these tabs one by one. Always follow the concept behind this. Okay, always follow the concept, not one by one procedure actually, because main thing is concept behind this. Procedure could be changed for every person, so do it quickly. Now you can see I have added extra length factor and total bend or lapping length actually, which is for you. If sometimes we need to put exact bending and lapping length, then this tab should be there to put values to get exact steel quantity actually. If you don't want to enter this value, left it as equal to 0, and you can enter here numbers 0, 1, 2 or 3, because this is numbering actually. This could be 4 times, 6 times. Okay, you can already adjust this standards value. Okay, after that one thing we should remember that our plans dimensions or units are in feet actually. So we are working in feet, so remember always to add unit as well, because this could be wrong quantity of steel quantity, so always add a units as well. So these values should be in feet. We must enter here feet to remember every time that this should be in feet. Okay, feet. After that bar weight, which is in kg per feet, actually. After that sides should be in feet, because this is the dimensions. Longer or shorter side, spacing should be in feet. This should be in feet. This should also in feet. Number of side in each, actually this is numbers, total number of, this should be in feet. Extra length should be in this should be in this is actually factor, so you can left it as it is, and you can put each also So total length, what is total length, should be in feet. Okay, and now I want to see these. First of all, go to layout to see how our command will look like. Go to form layout. You can see this is not showing me a diameter, bar weight, sides, a b, spacing. It is here. To see these tab in our command, you must tick this option. We want to see dia, bar weight every time, low sides, spacing, both sides, bands, lapping, total band, and extra length factor actually. Okay, so put 1.2 because this is standard value. You can change it when you are using command. If you don't want to change, you can left it as 0, as I am doing, because I don't want to put bending, total bend or lapping length actually. Spacing should sometimes 6 inches or different in both directions. Sides okay. Now I also want to see, now this tab is showing here, and I want to organize these tabs here like this and show dia and bar weight in a same row. Clicking on this, and I want to see units as well of this and this. This should not be there because this should be in only in formula. I want to see, put these two values, and this will automatically update it from these two values actually. So untick this option from back. Extra length factor should be there, and sides should be in a same row like this. Sides okay. Okay, click on okay, and now I want to see, don't want to see this, don't take this option because this should be like this. Bend length multiply by number of bands, this should be total lapping length actually. Okay, so always remember, and to enter a formula, the concept is always remembered. So to calculate the total length actually, first of all we must calculate the number of bar of each side. So to calculate the number of bar, we must drag and drop like this. Side A divided by spacing, this is longer side, and the spacing along the longer side should be drag and drop like this, and this should be added with 1. Now this will result in number of bar of one side actually. This should multiply with side, this should multiply, this is number of bar should be multiplied with the length of bar actually, and length of bar is actually shorter side actually. Go to this, and now you have to add a extra, multiply it with extra length factor like this. Okay, now add this, and now drag and drop like this simply here. Now side B should be there, and with the shorter side and spacing along the, you must add. side B, shorter side, should be divided by the spacing along the shorter side. Okay, after that this should be along the longer side, length should be along the longer side of bar, and this should be multiplied with a factor of safety for the extra length actually. Now this should be deleted. Okay, our formula has been successfully made. Here this is showing me error, so always see this error type of errors. You must recheck your formula correctly. Now this formula is okay. Now this error, sometimes this error is due to not putting correct brackets actually, because this formula is too long and one bracket could make an error. So it is amazing that it always warn us before our actual and important estimation, or before running any command. So this is amazing tool actually. After that, this total length of bar should be multiplied with the unit of bar to get a quantity, and this quantity this is number of that type of slabs or a foundation. So count should be multiplied with the total length of bar, and this should multiply with the unit weight of that bar actually. Okay, you can round it as, and this result in kg. Okay, now our formula has been made successfully. So let's try. Suppose these three are our main foundation slabs. Okay, so to calculate reinforcement for this, let's suppose run this command. Let's suppose these three slabs are exactly same in dimensions and in reinforcement detail actually. So first of all we have to add here diameter. Suppose dia of the bar, let's say bar of 10 mm dia should be in feet 0.032 actually. Okay, and bar weight for 10 mm dia, and as we are using a 10 mm bar dia which bar weight actually is 0.188 kg per feet, and suppose sides both sides longer and shorter is exactly same. So put here 5 feet by 5 feet is slab dimensions actually, and spacing of bar along the longer and shorter side is 6 inches. Suppose after that zero bend, no such detail is given, so I have to put here bend and number of bend equal to 0. Extra length factor is actually 1.2 minimum. Always remember you can increase this value, as this is up to you for your estimate actually. Click OK. Now you have to one by one. Select slabs. Now these are our 3 slabs, and this is our count, and this is not visible actually. To see is visible, go to settings, take off settings. After that you have to increase the point size. You can right click here, also increase from this, click on scaled. After that, one by one. Now this is size remains same for you at every time. Okay, now 3 similar type of slabs or a foundation or a pad footing slabs result in 76 kg, required a 76 kg steel at a site to construct for the construction. Actually go to this steel quantity, and 76 kg steel is required, and you can increase, you can put a cost actually here, and wastage factor 10% actually normally, or bar pricing, you can put pricing here as well to get a total quantity, total price of that quantity actually. So after that we must see how we can calculate the steel quantity for the slab, beams and columns. This is quite similar, and the always remember behind concept will remain always same, only thing is procedure which could be different for every person. So let's quickly do it now. For again making same command, we can copy this command and exactly paste here, and only thing we have to change here some things, steel quantity of column, and this should be column or a beam you can say. Okay, go to advanced. Now one thing you have to remember that for the column and beam we must remember that there is a linear length which is 3rd dimension actually. This should be required for the column, which in column this length is called as total height of the column, and in beam the 3rd dimension is usually called as a linear or total length of that beam. Okay, so always remember. So we must have to add total you can column height actually, height or a beam length actually in feet actually. Okay, this should be added in estimating tab, so group should be in estimating. Now one thing is also different here, which is that in beam and column there is no center to center spacing sometimes. Okay, center to center spacing is required in beam and column only for ties, or which is horizontal reinforcement you can say. Okay, so for the longitudinal reinforcement we must add a number of bars tab actually, number of bars longitudinally. Okay, click OK and tab has been added. We want to see these number of bar every time and column height every time, which unit should be in feet, and this unit should also in feet. Now one thing you have to recall that in your BSc course of civil engineering you have learned about formulas to calculate total length of the ties or stirrups you can say, and total length of the bar longitudinally. So I have to must recall it now. Now to calculate the steel quantity we always must calculate the total length of bar to multiply this total length of bar with the unit weight of that bar, okay, to get a steel quantity. So main aim is to calculate the total length of the bar, and total length of the bar should be equal to length of the longitudinal bar. In every case, in it could be in for the columns or for the beams also, total length of the bar, total length of the longitudinal bar and total length of the horizontal bar, which is known as stirrups or ties you can say. Okay, so to calculate the total length of the longitudinal bar, this is quite similar as we have done earlier, that it should be equal to the number of bars. It could be 4, it could be 5, it could be any number, and this should be given in our structural drawings, that how many number of bars is given in longitudinal direction. Okay, so here is the number of bar, and after that this should be multiplied with the total length of the longitudinal bar, and total height of the column is should be equal to the total length of the bar, and this height of the column will add some extra length factor, which is for sometimes for lapping, for bend. This should be always added, okay, in the total length of the or total height of the total length of the beam or total height of the column. Okay, now look, after that total length of the horizontal bar should be calculated from this formula. Number should be multiplied with the total length of the one stirrup bar. Okay, so one stirrup bar or a ties, we have to recall our syllabus that as if our column or a beam is in rectangular shape, then the ties or stirrups should be calculated from one side plus second side, and this should be multiplied with the 2 to get a rectangular or total you can say total length of the that stirrup. And this should be always multiplied with the factor of safety for the extra bend up bars, for bends, for lapping, etc. Okay, and this is usually minimum factor we use at during estimation, which is 1.2 actually. So number of bar, how to calculate the number of bar horizontal for the stirrups actually, and for the stirrups number of bar should be calculated from this formula, and this should be equal to the height of column should be divided by the spacing of ties, which is given in our structural drawing, should be added with the 1 to get a total number of bar actually. So we have to change this a little bit, spacing along for spacing for the, you can say it as ties or stirrups. Okay, now this should be deleted, this should not require. Okay, now we have to do this formulation quickly. Okay, always remember the formula and the concept behind should be seen. Now formula is made successfully for both beam and columns actually. You can see from here. Also going to this option, number bar, how our tab is look alike actually. This should be in each actually. Click OK to use this command. Now first of all we will use it for beam. Suppose this is these are 3 or 4 beams which we want to calculate steel quantity, and its length is actually 3.3. okay, run this command for the beam actually. Now put here beam length actually, which is 3.3 feet actually. After that, suppose number of bars we have here for this beam is 4 longitudinally, and the bar dia is 10 mm, which is approx 0.0325 feet, and 10 mm bar has a unit weight of bar which is 0.18 kg per feet. And sides suppose this is 1 feet by 1 feet beam actually, so 1 feet by 1 feet, and stirrup spacing center to center is 6 inches, which is 0.5 actually. No bend or lapping is required here, suppose. And the wastage factor or extra length factor, which is minimum 1.2 actually. Click OK. Everything is okay. Click 1, 2. Always select those beam which have same specification, same dimensions actually. Okay, always remember. So for this beam, 42 kgs of steel should be required for longitudinal and stirrup spacing actually. After that, for suppose these are 4 beams, columns, to get quantity for columns. Similarly, suppose height of that column from the sectional, from the elevation view, we have suppose 8 feet height of that column. Number of bars, suppose 4, 10 mm bar having a bar dia of this. Sides 1 by 2 feet suppose. After that, click OK. Select 1 by 1 columns. Now click escape and click on press N to escape this command. And these 5 number of columns required 154 kg of steel at site to construct, for the construction of these columns actually. Hope so this will add some extra linear measurements, some extra idea about how we can use formula making technique using a Planswift software for the every type of estimation. You can say only change will be in formula or concept behind this. Okay, always if you are good in estimation formula or concepts, always work on concepts. Then this is only a game, only a playing game for you. This is very easy procedure actually. Okay, see you in next video.